Hello and welcome to our session on security risks and concerns in UiPath. My name is Alon Dankner and I'm a security researcher at Nokod Security. Today we'll see some interesting attack scenarios and vulnerability against UiPath workflows. So we'll start with some injection attacks. We'll see HTML injection, SQL injection, and command injection. Then we move to some supply chain attacks, where we'll see pre-usage infection via third-party components and dependency confusion attacks. Our first example is HTML injection. In this example, we have a public flow, flow that is open to everyone, that takes orders from customers. Now, the submissions are written to a Google spreadsheet, and the new submission triggers a UiPath workflow that handles the submission and sends an email to the seller with the order details. So let's see now how a normal user fills the form. So we have the name, the email address, the requested item, and even a message for the seller. Now here we see the mailbox of the seller, and here is the email with the order details. Now, the UiPath workflow uses an action called send email to send the order details. An attacker can exploit this workflow by adding an HTML code to the body of the email. And since there is no input validation and the flow is vulnerable, we'll see that the email client of the seller, the victim, will render the HTML code and execute it. So let's see our demo. Again, the attacker fills in its details, even puts the requested item, and in the message, we see here an HTML code with a link to a website called evil.com. An attacker can use it to a phishing attack or even to exploit vulnerabilities in the browser of the seller. Here we can see the attacker lures the seller to click on the link and direct him to evil.com. I'd like to emphasize that this email comes from an internal address. So it first shows some credibility for this message, and second, this bypasses some security products that might try to detect this attack. Now here we can see the UiPath workflow that handles the submission. And here is the send email action that sends the email, and we can see here the variable that contains the user input right inside the email body. So this is the source, the root cause of the vulnerability. Our next example is SQL injection. So we have the same setup as before, and additionally to the order email, the flow sends a confirmation email to the customer with his order history. To get the user's orders, the workflow accesses a database that contains the order history. The workflow uses the customer's name to fetch his order history. And we'll see that an attacker can use the name field to exploit the workflow and inject an SQL query to expose sensitive data. So here is a normal run of the workflow. Again, the customer fills its details. Now we see here the mailbox of the customer, and he receives an order confirmation. And we can see here the last 3 orders of the customer. So now let's see what the attacker can do. Now the attacker in the name field enters a weird looking name. There's no one called John Smith, and 1 equals 2. And we clearly see here an SQL statement. But now, when the attacker receives the confirmation email, we see that instead of receiving the order history, there's actually a list of emails and passwords. Admin123, princess. These are not orders. This is the users table. So what went wrong here? We can see here again the flow that handles the submissions. And here is a run query action with the SQL query. And the vulnerability is exactly in the SQL query where there is no input validation, and eventually the name that contains the SQL statement extends the statement that the developer meant to send. And this is how the attacker retrieves more data than it should. So now let's see our command injection demo. Now imagine this flow of a finance guy that gets a lot of invoices and contracts that need to be saved for later inspection. Now, instead of saving all these files manually, he uses a workflow to automate this process. Now, the flow is triggered by any email with an attachment, and the flow compresses the attachments and saves them to the downloads folder on the guy's computer. Now, we'll see that this flow is actually vulnerable to command injection, and that a malicious attacker can inject a CMD command into the file name, and the workflow would actually execute this command. So now let's see our demo. So here's the workflow, which is triggered by an email with an attachment, and the flow downloads all of the attachments to the downloads folder, then compresses them to a single zip file. Now, the issue in this flow is the use of the tar command in the CMD process. Now, we see here that flow uses a list of the file names at the end of the command. Now, since one of them is actually a command, the flow would actually look at it as if it was a legitimate CMD command instead of a name. Now, we see here the list of documents, a long list of documents. You can't even see the last one. And just at the bottom, there is a file name that with the name doc.txt and calc exe and echo, which is clearly a CMD command. Now, let's use the assistant to invoke this workflow. Now, the assistant downloads it and executing it. And surprisingly, we see here the calculator running, and instead of the calculator, this could be any malicious code that could run on the local host. Could be WannaCry, could be any other malicious code. So now we enter the realm of supply chain attacks and third-party attacks. So UiPath, just as other low-code, no-code platform, has its marketplace where the developer can use existing components in his workflow instead of developing them on his own. Now, clearly, malicious components implemented by attackers cause a problem and risk to the user and the organization. Now, in this demo, we'll show you that even considering a workflow without running it allow the attacker to execute arbitrary code on the host of the developer. So let's see the demo. We see here the UiPath Studio, and here's the package manager. Now the developer adds a new dependency to his project. Now, he didn't run it, he just added it. And still we see here a message box of the attacker with a hacking announcement, which demonstrates that the attacker can run any malicious code on the local development environment. And as before, this could be any malicious code. We conclude our session with the dependency confusion attack. Now, the developer in UiPath, when it uses dependencies, it specifies the version of the dependencies that he wants to use. Now, there are two options. In strict versioning, the package manager looks for exactly the specified version. And if it does not exist, it fails. To avoid it, we have loose versioning. This means that if the specified version does not exist, the package manager will look for the next version above the specified version. So for example, if the developer asks for version 201 and this version does not exist, the package manager will search for the next available version, for example, 207. Now, for this search, the package manager looks in several package feeds. For example, in a public feed called Nokod.org. And since this feed is public, attackers can also access it and may upload malicious packages to these public feeds. So let's see how it works. We see here UiPath Studio, and this is the package manager. And the developer adds a no-code Fibonacci dependency. And this dependency uses the Fibonacci calculator dependency. So it is a dependency of dependency. And this one is specified with loose versioning, which means it searches for at least version 201. And as we saw, it found version 208, which is the next version. Now we built this simple workflow and tested it, and we see that it works just fine. So let's see the attack. The attacker first creates a legitimate package called Fibonacci and uploads it to the marketplace. Fibonacci, as I said, uses the Fibonacci calculator with loose versioning. Then the attacker adds another legitimate package of Fibonacci calculator, version 208. And then the attacker adds the malicious package version 207 to Nokod.org. When the user tries to add the Fibonacci package as a dependency, it will now look for version 201, which does not exist, and will find the malicious package version 207. And this is how the attacker manages to run malicious code on the local development environment. So here we see Nokod.org. Here's the Fibonacci calculator. Version 201 does not exist, and version 208 is the legitimate version. Now we'll see how we can upload version 207, the malicious version, to the Nugget feed. Okay, this is the malicious version. It is now uploaded, and it says it is validated, but it will be approved. So now going back to UiPath Studio, The victim, a legitimate user, tries again to add the no-code Fibonacci dependency. But this time, when the package manager looks for Fibonacci calculator, it finds the malicious version. We have just seen the hacking announcement that we saw before in our previous demo. And this message box shows that the attacker indeed can run arbitrary code on the host. Thank you so much for listening. If you want to learn more, please visit our website, nocodsecurity.com, and you'll find there more information and more interesting stuff from our research team. Thank you.